Hi, I'm Neharika. I'm currently working as a machine learning software engineer at Google Band. And in this video, I'm going to talk about a recent paper by Meta AI, which proposes a method to basically reduce hallucinations in large language models. This method is called chain of verification. So let's get started. I'll start with some context. So, large language models are trained on massive data sets of text, each containing billions of words. And it is seen that as the model size increases, its performance also improves, and it we see that it generates more accurate and factual statements. But even with the largest of LLMs, we still see that it makes mistakes. And what we see is it specially makes mistakes on lesser known facts or something that occurs very infrequently in the training data, or maybe it is not occurring in the training data at all. So, what is exactly a hallucination in LLM? These factually incorrect generations by a large language model are called hallucinations, and what LLM tends to do is it generates a very plausible looking alternative response. Let's see an example. So I tried it using Google Bard. I'm asking Bard about some of the politicians born in the New York City, and Bard responds with multiple politicians, and I've not copy pasted everything here. So I've pasted only one of the politicians, which is Hillary Clinton. Why I have pasted this is because this is a hallucination. Because Hillary Clinton is actually not born in the New York City. So now, since we've understood what a hallucination in LLM is, let's try to understand what is the approach that Meta AI has proposed. So, the chain of verification method basically consists of four steps. The first one is to generate the baseline response. So, we give the LLM a prompt or a query and it generates the response. Now, in step two, what we try to do is we ask the LLM using the query and the baseline response to generate a list of verification questions. How does a list of verification questions helps is that it helps in the later steps to actually self analyze if there are any mistakes in the original response. Coming to step 3, now once we've generated the verification questions, we ask the LLM to answer those each of the verification questions. And now in the last step, we use everything which is coming from step 1, step 2, and step 3 and ask the LLM to generate a revised response. So it basically incorporates all the verification results over there, and given all the discovered inconsistencies, it will try to reduce the hallucination in the final verified response. Now let's see an example. So this example is from the paper itself, where we see that the query is again the same thing. So name some politicians from who were born in New York. So step 1 is to generate the baseline response, and if you see over here, so it generates the first one it generates is actually Hillary Clinton, and thus it is a hallucination. Now, coming to step 2, we ask the LLM to generate relevant verification questions based on the query and the baseline response. So, the verification questions look something like where was Hillary Clinton born, where was Donald Trump born, and so on. Now, in step 3, we ask the LLM to answer these questions. So if you see over here, it says for the first question, Hillary Clinton was born in Chicago, Illinois. Now, this is something really important because if you see, the baseline response actually contradicts with the execute verification step, right? So, what is happening here is, and that's the main trick of this method, that LLM seems to be more accurate on short form questions than on the long form generation. Now, once we have these verification answers with us, we go to the step 4 where it uses everything from all the verification questions and answers, and it tries to revise its response. And if we see over here in the revised response, we do not see Hillary Clinton. So this has reduced the hallucination in the response. So the experiment which was done was compared with Instruct GPT, Chat GPT, and Perplexity AI, and we see that this chain of verification method with the 65 billion model seems to be outperforming all the above three models. And what you'll also see is they have different variants they've tried in chain of verification method, which is joint, factored, and factor plus revise. So quickly covering what is the difference between joint and factored. So the major difference is that in the joint method, they try to club in the second and third step together. So it means that the baseline response is there and the LLM is asked to generate the questions along with the responses. Now, since the baseline response is there, the chances are that since the baseline response contains hallucinations, thus the question answering in step 2 and 3 could also contain hallucinations. But in the factored approach, they try to segregate both these steps 2 and 3, and they do it sequentially. So they first ask the LLM to only generate verifications questions, and then in step 3 they do not show the baseline response and they just ask LLM to answer to all the questions and coming from step 2. Now, I tried it out even in Google Bard, and this method seems to work pretty well over here. So I asked Bard that where was Hillary Clinton born, and it seems to answer it correctly. It says Chicago, Illinois, and not the New York City. Thus, the major thing over here is that we see that the short form verification questions are more accurately answered than long form queries. And this paper states that this method has provided very large gains in precision on question answering, list based tasks, long form generation. And what they also observe is that the open verification questions outperform the only yes and no kind of questions. So, yeah, that's all. Thank you for watching.